And we're like, hey guys. Okay, so like we said, today's just review, so we're not gonna have to worry about posting the link for this. This is just going over because the exam is due tomorrow.
Mm-hmm.
And we have to take it in the eye center.
Oh, it's due tomorrow?
I'm kidding. I don't know about the eye center. Probably not. If I'm correct, yeah. Eye center. Everybody fly here. Go! Yeah, Unit 1 exam closes Wednesday, May 23rd at 11 p.m.
Javi, el examen es para mañana, ¿oíste? Mueve la broma para acá y sube. La mesa, ponla aquí. En ese sitio. No sé. Búscale puesto. Armando, ya. Okay.
But yeah, so if we look at the lesson 8 thing review for exam 1, it literally is just everything we need to go over before we take the lesson 8 meeting quiz. Which, speaking of that, I'll get it up.
Are you talking about all 32 questions?
The what?
Are you talking about the questions or?
I don't know if we need to necessarily go through that. We just need to make sure that like we know how to do it.
Oh, okay.
Yeah, I'm not saying we go through each and every one. No, that's death. But like, we should be able to look at it and be at least explain it to each other, like how we would do it. But let's see. Because it's like, okay, distinguish between a categorical and quantitative variable. And so that's just like, quantitative is like numbers, right? So, it's the variable based on like how many trees there are, whereas categorical is like all of like types of trees together. Does that make sense?
Mm-hmm.
Okay. All right. Yeah, so I'm not sure how to do this because it is just review. It's not a lesson. So this is really just up to you guys how we want to take it. If we want to just quickly go through everything and just bounce off and make sure we know it.
Or how about, do any of you guys have like any problems with any of the questions?
I don't have. I'm pretty sure that I get a lot of confused when I'm doing the exam. I think it's because I'm kind of nervous. It was the same with the math, the first math that we saw, and I just try my best and always get like C or B, and I'm happy with it.
Okay. I don't mind, like, the only thing on mine, like, that I kept missing was sometimes I wouldn't read the answers all the way through. And so I'd fill them out and I'd solve them and they were right for the wrong numbers.
Yeah. And I just have kind of a
Bless you and all your prosperity. Bless you squared.
Anyway, I write down all the formulas and I just try to recognize whatever I have and I try to get the answers, and yeah, I think that there is not too much that we can do for the other in the exam, but
yeah. Okay, so do we just want to like jump start into the quiz then? I mean, if it's literally just review, then we've been doing enough that we should be able to get it no problem.
Yeah.
Okay.
And I'm pretty much sleeping right now. I'm taking water to wake up.
Oh no, I get you. I just danced for like 2 hours. Oh, hold on. sorry, I'm making food because I didn't realize that this week in my Psych 111 class, we also have 2 chapters due. And I'm like, why do you do this?
Aw.
So now, because I didn't know, so I didn't budget my reading right. You're good. Okay. So question 1 for the quiz.
There's
Whenever it loads.
31 questions.
Oh dear.
I think true is good for everyone.
What?
True.
Drew?
Yeah.
Who's Drew?
Read the question.
Oh, hold on. Oh, true. I thought you said Drew, and I was like, who's Drew? Why do we need him? I don't see the relevance. Okay. Enable editing. Okay. So 2. Which of the following variables are categorical?
Super easy.
That's a randomly selected brand of toothpaste at a convenience store, right?
Yeah, you have 2 ones over there. So the first one, that is the number of animals in the local zoo.
Okay.
Randomly select brand of toothpaste at convenience store.
Okay. Yeah, because that makes sense because there's no numbers.
Yeah.
Really in those specifically. Okay, all right. The mean IQ test score in the U.S. is 100. 20 randomly selected took an IQ test. Mean scores was 112. Which of the following statements is true? Parameter, statistic, or statistic?
So yeah, so it says like the mean or the IQ test score for United States is 100. So for me, that one is the perimeter, that thing.
I would agree because that's like a starting parameter, and then these kids obviously they got their mean higher. So
yeah.
And then
we all agree on that?
Because they say 20 randomly selected statistic students, then for me the 112 is a statistic.
Okay, so hold on super quick. With question 3, it says which of the following is/are true? So would that make 112 a statistic?
Yeah.
Yeah.
Okay.
First one is you have to select 2 options because those are true.
Okay.
100 is a how you say it? Perimeter. And then the other one, 112 is
okay.
Static. Exactly.
All right, so the next one says, Rotham City has 4 distinct neighborhoods. Property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One has very low property taxes, another has extremely high. Property taxes are usually roughly proportional to property values. What type of sample should we collect to gauge the residents' responses to proposed increase in property taxes? Well, I'm going to say, for the sake of it, a cluster and systematic are out.
I think it's just the one that says is stratified.
Stratified, yeah.
Remind me what stratified is. My brain's kind of blanking.
It's when... Oh, go ahead.
No, you're good.
All right, it's when subjects are in groups according to similarity of some characteristics, and then specifically take a simple random sample from each group.
Okay, yeah, I'd agree with that. Because I was like, I don't know if random sample would necessarily be the best, because you could just randomly, literally get all rich people. So, let's go stratify.
And when does... They put, like, every group that have something in common, they put it in, like, boxes. I picture in my head that way. They put it in boxes, and then they take one from each, and then they make that's how they get the sample. So that for me is stratified.
Yeah,
that's how I get it.
All right, so question 5. When design experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, fourth grade students in that district. The experiment is then conducted using all the students in the selected classes. What type of sampling scheme is implemented? Wouldn't that be cluster?
Yep, you get it.
Mm-hmm.
Okay. All right. 6. At a school fundraiser, the name of every person who was attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? I would say simple.
That's
Like SRS.
Yeah, random.
Just because there wasn't any pattern to what they picked.
Nope.
Okay.
Yep.
A special interest group is conducting a survey regarding wolves in Yellowstone National Park to accurately, I can't English, gauge opinions on both sides of the political spectrum. The researchers took the list of registered Democrats and selected a simple random sample of 100 people. They then took the list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? I'd say systematic. Because they took one thing and then randomly picked in that next thing, and then took that thing and randomly picked into a smaller sub.
Yeah, but they spread them in size of politic spectrum. So, and I mean, even when they pick randomly 100 people from one box and 100 people for the other box, they make a separation. So for me, that one is also a stratified random.
Stratified?
Yeah.
That's what I was thinking.
That's for me.
Because a systematic sampling is when subjects are in some sequential order, and then you randomly select one subject and then ask every 10th subject, if that makes sense.
Oh, that's systematic, right. Okay.
Mm-hmm.
Yeah, let's go stratified random. Okay. A survey was taken of the purchases at the crossroad. Open the data file. I've got that. And use this data to answer the next 3 questions. Using software, calculate the mean amount spent, which we can all do, or you can just watch me do it. I mean, whatever you want. Okay.
I think these are the same questions that were on the textbook review question things. Because I remember these.
Oh, that's funny. All right, there we go. Enter. All right, looks like the average is 4.77.
Let me see.
1, because you have to. It says round to 3 decimals.
I didn't see that, but round.
No, you're fine.
Yeah, so 4.771.
Yep.
Okay. Using software, calculate the standard deviation of the amount spent. So that was mean. This is SD. And then we have Dev.
It would
There we
be. There you go.
What do you mean, few? Oh, did I use the wrong one? Probably. Yeah.
Start with an S.
S starts with an S?
Yeah.
There it is.
There you go.
Thank you. Now let's.
So you take the mean.
Yeah. This one is wanting us to use the machine, though. There we go. Like the settings in Excel, which is why if you look at the screen share, that's why I'm showing you guys. But so the answer I got is 1.900. Oh, 1.901.
Yep, that's what I got.
Okay.
1.901.
Yeah. All right, and then start by creating.
I get 1.912. I don't know why, but that's okay. I was sleeping.
Maybe, I don't know. Okay, let's look at the next problem. Okay, oh, it wants the histogram. Okay, let's see if I can remember how to do this one. Let's go. Data. Wrong one, I think. Insert. Gotta remember it, because I haven't used this one in forever. Feels like it. Data formulas. Is it under formulas? Give me
It would
something.
be under charts. So go to insert. And then there's charts right there.
Oh, hold on. Before we do that, probably should highlight all that, huh? Insert charts, all charts, histogram, and just this classic one, right?
Mm-hmm.
Cool. Okay. All right, so that's our histogram.
And then you
yeah.
Looks like it's skewed right? Skewed right. Yeah, long tail right.
That's yeah, I think.
Oh, okay. Guess.
I just confused myself. Ignore me.
No, you're good. No. I was sitting here because I was like, oh, they're going to be asking us more questions about it. No, Jessica Meir and her research team measured the body temperature of a sample of diving elephant seals. A thermistor is placed at a specific location in each seal to measure the body temperature. Thermistor is placed.
Mm-hmm.
Body temperature was calculated to be at start of dive was that. Complete the following table and use your work to answer the next 4 questions. Okay. So what we need to do is get that mean. So first of all, I'm going to minimize that and I'm going to whip out a calculator. So we have 37.91 plus 37.25 plus 38.98 plus 38.16 divided by 4. That was not right. I accidentally did times 2, guys. Ignore me.
The mean is 38.075.
3.147. What?
My calculator got 38.075.
Oh. Okay,
So this one it says that we have to look for A, and then we have to look for B.
Well, yes.
Okay.
But we need to get the mean first. That's what it's looking for.
Okay.
Are those formulas? And so we're trying to calculate. Kate, you and I just type it in again. There's some.
That's what I'm doing.
That's 37.2.
I got the same thing.
98 plus 38.16 and divided by 4.
Oh, there you go.
Okay. So 38.075. We don't need that one just yet. Okay. That's marked A. All right. And you said the mean was 38.075?
Yeah, and that's what you got.
38.075. Okay. So negative 0.165 is the answer for A.
Yeah.
And then for that one...
What was the answer? Okay, there you go.
Yeah. And then for B, which is the next question, that's what I was looking down to go see. We need to go 37.25 minus 38.075. Enter.
The square, yeah.
Which is 0.681.
Yep.
Which quantity is equal to the sum of numbers in the squared deviations column?
What do you think that is the answer? Because
well, part of me is wondering if we do need to go through and solve every individual thing, or if there's a simple answer that I'm not looking at.
Because you say that square deviation is just like a standard deviation, I think.
Let's see.
That's to the square. And I don't know.
Well, no, standard deviations are square root, so they couldn't be the same. And the variance from the mean, or the variance, could potentially be, But the same with the mean. But no, it couldn't be the mean. So it's either none of these are correct or the variance, because I mean...
Yeah, I think none of this is correct. That's my answer.
Kate? So the two we have left are variance or none.
What do you say, Carrie?
I don't think any. I don't know.
You don't think any of them are correct either?
Yeah.
Cool. Move on.
We can go, yeah.
Okay, what is the standard deviation of these temperatures? Okay, let me open up Excel, scroll down a little ways, get away from everything. Can somebody read me off those numbers?
37.91.
Okay.
37.25.
Okay.
38.98.
Okay.
38.16.
All right. So I've got those four numbers. Now what we're going to do is we're going to equals. There. 0.619.
See, I have 0.715. Why?
Wait, maybe. Do you guys remember he said that sometimes Excel wasn't correct with standard deviation?
Oh, yeah.
Okay, so Kate, will you manually solve this and tell us which answer you get? Because if so, then we'll go back to the other one super quick.
Yeah, I'll do that real quick. Whoops. Okay. Oops. I got 0.619.
Okay, even when typing it in manually, you got that.
Mm-hmm.
Okay, so 0.619.
619.
Okay.
Okay, and you didn't type that through Excel, right?
No, I found a calculator online.
Okay, I just wanted to double check. Because I'm like, we need an unbiased non-Excel. Under certain conditions, the standard deviation can be negative. Yeah?
That's false.
No, the standard deviation can. The squared, right? Like, the squared deviation can't. But the standard could be.
I think it's false. I don't know.
Well, because what's the formula for standard deviation?
Give me a second. I have it right here.
No worries. Because isn't it
Okay.
like your x minus your mean over the number there is minus? No, that's the mean, isn't it?
Yeah, so it's the square root of x minus mean squared divided by n.
Okay, so n could be negative. If it was just like square deviation and you had to square it, then yeah, it could never be negative. And square rooting doesn't necessarily take away a negative, if I'm correct.
But n is not population, I think.
Oh, right. Yeah.
So there is no way the population can be negative.
It could be a pessimistic society.
Yeah. You know what? I think that we are talking about souls. So they have to be negative. I don't know. I think it's false, but I don't know.
No. I agree with that because the minute you pointed that out, it was like, okay, that makes sense. If n was any other number, I would have been right. Okay, next question. Could somebody else read that? I'm trying to make my mac and cheese because I is a hungry sushi roll.
I can read it.
Thank you.
In the same study, the researchers placed thermistors, temperature sensors, in the three seals, near their spinal cord and brain in the extradural vein. They placed I don't know how to say that, in 6 other seals in their aorta, the largest artery in the body. Finally, they placed thermometers in 4 other seals in their hepatic sinus. The results from the study are summarized in the table.
Okay.
Which location resulted in the most consistent temperature measurements from one seal to another?
Oh, dear heavens. Okay, so the mean was X. Most consistent temperature measurements. Is there a mean? Do we have like a normal mean?
No, I think that we have to look in the standard deviation, because the standard deviation is the one that it goes like this. Is the one that is a I mean, this is the way that I believe that is a standard deviation. And if the variation on one situation specific, like let's say that we have a couple people that they buy in the supermarket every 3 weeks, and we have another one they buy about 5 weeks, and then when you use all this data together, then you're gonna get a standard deviation that is like most likely all the people do this. So
okay. So the smaller the standard
less
deviation, the more consistent it is?
Yeah.
Yeah.
The less
So-
is the standard deviation, the most consistent is.
Okay.
I think it's the extra dural.
Well,
Yeah.
that is the smallest number. So I would agree with you there. Do you agree, Estrella?
Yeah. I am.
Cool.
Okay. Next question. The number of hours students spend studying for an exam were recorded. The data are represented by the box plot below. What is the third quartile?
The third quartile, let's see. Q1, Q2, Q3 should be 8.
Yeah.
Yep, that's what I was thinking.
Cool. All right. Oh, I was looking for multiple choice. What percentage of the data lies between 4 and 8 hours? Oh, dear heavens. Because Q2 is the mean, right? I would say 50. Yeah, it's like that middle black line. That's the mean,
That's the
right?
Median.
Median. Okay. Oh, right. Median is the. Okay. Well, in a typical box plot, that's usually 50%.
Yeah. Because it's right in the middle.
Input only 50. Okay. All right. Let's see. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. Central contaminant harms the city's water supply. Above 10 ppm are considered a health risk. Between 1.925 2.52, we will assume U minus 2 times the standard deviation is 1.59, and U plus 2 times the standard deviation is 2.5. Okay. So what is the estimated mean, or what is the estimated mean of the measured nitrate concentrate in Rexburg's drinking water? So that one's simple, hopefully, maybe, or might not be.
Yeah, you just have to add all the reports and then find the mean. And thus, for me, it was 2.055, but I was sleeping. So, say again, because I've been missing all the answers with calculating.
You're good, because I'm trying to figure out how to do this, because in normal algebraic formulas, you would subtract and divide and do all this stuff.
The mean, remember that the mean is you plus all the numbers and then you divide them by the amount.
What?
You know how?
I'm sorry, I'm confused.
You have to plus the 1.59 and the 2.52, and then divide.
So what did you get for the mean, Estrella?
2.055.
That's what I got.
Okay, so question. Is this just one where we do the backwards standard deviation formula? So like we would plug the other two in like to the Omni calculator we've been using?
That would be the z-score.
Oh, right.
Yeah, this one is mean. Just remember that mean. You take all the numbers that they give you.
Oh my
You
gosh,
plug
do
all those
we just take
numbers.
those two and divide it by 2?
Yeah, that's it.
Oh.
Yeah, I know.
What was the point, the number on that one?
2.055.
Okay. What is the estimated standard deviation of the measured nitrate concentration in Rexburg's drinking water? Son of a fish stick. That's squared deviation. So the formula we said for standard deviation was square root of x minus the mean squared over n, right?
Yes.
Yeah.
Yeah.
So, x was, it shouldn't change if we use one of those numbers, right?
I think you have to, do you remember that you take both means and then you take away one from the other? Do you remember that formula?
So
you take both means and then you just minus 1.59 minus 2.52, and it's gonna be your mean.
That's our mean, or that's our x?
That thing that goes in the box let me go and find the formula for you. At least the Kaden have it already.
You're good. I'm just sitting there because I'm like, mac and cheese is life, guys. Mac and cheese is life. And so,
well, what would be the n?
The 10 that is in the top.
The 10?
Yeah, in the top of the problem.
Oh my gosh. Oh no, that's nitrate conversations above 10 ppm are considered a health risk. That's just telling us that if it's over 10, it's a health risk. It's filler info.
Oh,
that's like an extreme. Yeah, because our mean was what we just got, and now it wants us to get the standard deviation. Honestly, I think what Estrella said was the best bet. 1.59 minus 2.52 minus the mean divided by n. Like, that's the only thing that makes sense with the info we have.
What if we took the mean and subtracted it by 2.52 and then divided that by 2?
My only worry there is we also have another number, and that standard deviation is going to vary too. So why don't we do this?
Oh, no, that's not right.
Let's all take
Ignore what I just said.
Okay. So let's do it. Caitlin, will you do it the way will you do it with 1.59, and I will do it on the screen the way Estrella was recommending, which is 1.59 minus 2.52, as I'm dyslexic. There we go. Minus 2. What did we say? 0.055?
Yeah, that's the mean.
0. Yeah, because we do need the mean here at some point. Okay.
And you want me to just put in 1.59?
Yeah. And then let's divide that by 2. Okay, that looks close to what it could be. 1.49.2. 1.4925.
Let me see, because I get that one, but I'm trying to remember how I get that one. And I get 2. No, that wasn't that good. 0.233.
The standard deviation. Oh, I didn't square root. Hold on. Nope, it got mad.
I don't think you can square root a negative number.
Yeah, it just occurred to me.
Just click on your history.
What?
Yep.
Whoa. So times -1.
The first one is in the data set and the population mean. Population mean is mu.
There we go.
Was that the same answer?
So it was.
And then you need to square it divided by n, which is all of the numbers in the set. Then you got to take the square root of the whole. That's the population standard deviation. So let's say if you have just a sample of a population, not the information. If you just take out of the entire data, then you want to use this one. S, which is the standard deviation, is the sum of all of every point and the mean. That's the sample mean. In the other equation, we had the population mean represented by mu. This is the sample mean, which is basically the average of all the data. You have to square it. It's going to be divided by n. And so that's how you calculate the standard deviation of a sample.
Yeah, I think that one is let me see if I can get this one from here, because they give us pretty much the same thing, and then they say estimate, and
which set of numbers has the greater standard deviation? Is it the one on the left?
where is it?
We need to understand the basic idea of standard deviation to know what it measures. Standard deviation tells you how far apart the numbers are related to each other. So the more spread out they are, the greater the standard deviation. 4, 5, and 6 are closer to each other than 3, 5, and 7. And you can tell if we plot on a number. Put 5 in the middle.
Yeah, it have to be when some formula that we used in the past, because
Here they are. Numbers.
The question is, what formula, though?
yeah,
3, 5,
I'm
and
looking
7.
at a video that I saw
So
and
at
see if I
the red point. The points in red are further apart.
I don't remember anything from
The
this one.
points in blue, they're very close together. So therefore, 4, 5, and 6 has a standard deviation in 3, 5, and 7. So sigma is low. Here the sigma value is high. Now go ahead and calculate the population standard deviation. This
I think I don't know why, but
set of numbers, 3, 5, and 7.
I keep thinking that the 10 he has something over
The
there.
first thing that we should do is calculate the mean. To find the mean, it's going to be the sum of all the numbers divided by 3. Now, because the 3 numbers are evenly spaced apart, the mean is going to be the middle number, 5. 3 plus 8 plus 15 divided by 3 is 5. So that's the mean.
I would agree with you on the 10, except for the fact that it's not the number of samples. It's nothing. It's just explaining that 10's too high.
It's going to be a sigma of every point on squared divided by 10. All of this squared. So here's how to use the equation. We're going to use the first point, 3, by the mean, and then square. Subtract from the mean and square. Then it's going to be 7
Okay.
Okay, so here, guys, I just want to head to the next question. Not that I'm moving on, but I looked at the standard deviations because it said one deviation away, so I subtracted those numbers and divided them by 2 to get the original deviation away from the mean. And here's the 4 numbers that came up. It was 0.698, 0.233, 0.792.
0.33 was the one that I get.
Okay. And Caitlin, what one did you get?
Oh, you told me just to do 1.59.
Okay, and what was that standard deviation you got?
No, you told me just to use that number.
Oh, no, I meant plug it into the standard deviation formula.
Oh, I'm tired. Give me a moment.
You're good.
Wait, was I using that for the X or the N?
X. N is still 2 from what we have.
Okay. I got 1.147.
Okay,
that obviously wasn't right.
What formula do you use to get the 2.055? To see if I remember this.
We just got the mean. 2.055 was the mean.
Oh, no. I mean 2.233.
Literally
0.233.
Literally all I did is I went to the next question because it's asking between what 2 measured nitrate concentration do approximately 60% of the data values lie, and I subtracted them and then divided by what I got by 2, because 68's one standard deviation away, like on each side from the mean or the median.
Mm-hmm.
And so I took that and it was like, oh, it was this number divided by 2. I was like, okay, this is the standard deviation for each aspect. So you go that far to the right, you get to the first mark. You go get that far to the left, you get that first mark. And so that's all I did. So then however we figure this out, it has to be one of those 4 answers. So how did you get 0.233?
I'm trying to figure it out. I think that I use... Let me see. So So he says that we will assume 1.59 is the value of U minus 2Q, and U minus 2Q is equal to 2.52.
Oh, duh! Oh my goodness! Estrella, thank you, bless you, and all of your posterity. So, you, okay, 2.055. Okay, so what we do is 2.52 minus 2.055, right? 4.65 divided by 2. That's standard deviation.
Booyah!
Thank you, Estrella. We worship the ground you walk on.
Yeah, please do the same in my exam. We're gonna do it together. And that will solve all our problems.
Seriously. Okay, so that means for the next one, it can only be, from what I did, B or D. The question is obviously like which way. I'm saying
So
it's D.
This one it says between what what to measure nitrate concentration do approximately 68 of the data value lie?
Yes, and that's the one where I could not figure out how we were going to get standard deviation. So I went here and I subtracted those differences and divided it by 2. And based on the deviation we just got, which is 0.233, and based on what I got, the only options that had the standard deviation of 0.233 were B and D. But
I think it's D.
It is D.
Yeah.
Because if we just did B, that would only be like 34% of the data.
Well, and 2.055 is the mean.
Exactly. All right. Use the information to answer the remaining questions. We're in the final phase.
Do you want me to read it?
You can. Honestly, I was just looking for numbers.
Okay. The admissions committees for most Masters of Business Administration programs require the Graduate Management Admission Test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and their standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted.
Okay.
What is the probability that a randomly selected student will score above 542.3 on the GMAT?
Okay. So this is that one formula we use that is it square root? I can't remember, but square root of x minus the mean divided by standard deviation divided by n.
Yeah, because you have all those numbers there. So you have to use it.
All but n.
And then you put it on the apple thing? Like the normal probability apple? Applet?
Yeah, we'd have to do that as soon as we get the z-score. Because that's what we're trying to solve is the z-score.
Do you mean the formula x minus mean over standard deviation divided by square root of n?
Yes. Yeah. Because it's asking us for probability. If it was just asking us for z-score, we wouldn't have divided by the square root of n. But the question is, what is n?
Population, so it should be...
There's no population.
Let me see.
The only numbers are 500, 600, like 542, and 120.4.
Well, maybe we use the other z-score formula where it doesn't have the n. Like use the Omni calculator.
Okay, let's try that.
Because we only need the z-score. It doesn't matter if we don't have...
Okay, so 500 is the minimum. Oh, hold on. What's the question say first?
What is the probability that a randomly selected student will score above 542.3?
Okay, I didn't know if it was saying the likelihood for them to get into BYU, because then we'd have to put 600. Because it said it's rare for students below 600 to get in. And standard deviation is 120 point what?
120.54.
Looks like our standard our z-score is negative 0.351.
Okay, put it on the scale, on the normal probability applet.
Yeah. And this is what's the probability the randomly selected student will score above 542.3 on the GMAT. And that's the one where we fill in both, right?
It's not negative?
Yeah, it is. So you put the negative z-score here.
Uh-huh.
So negative z-score is there, and it set it up. What I'm saying is we fill in this middle part too, right? Because it's greater than the mean.
Well, you put our mean as 500.
Yeah. Because it's asking, what's the probability that a randomly selected student will score above 54.23? Because if you read, it says mean of 542.3, standard deviation of 120.4, minimum is 500.
Holy crap! Sorry.
No, you're good. And it says, but it's rare for scores less than 600 to be admitted. And this is saying, what is the probability the randomly selected student will score above 542.3? And so I just figured we didn't need that one because it's not talking about admissions. It's just talking about their likelihood to get there. But then again, maybe we should use 600.
How is it? How is the area then it's gonna show you?
So that changes it from 500 went to negative 0.35. 600 gives us a positive 0.479.
Why would I don't think we would use 600 for this question though. That's
okay, so what would be our x?
Well, I think it's either 500 or 542.3.
Well, 542.3 is our mean though.
Exactly, so it'd give you 0. So I think it'd be 500. But
okay.
Then you only fill in the right side because that would be above, because it's above 542, not 500 and above.
Well, yeah, that's what I got here, right? Or you mean that too?
That is what I'm thinking. I could be wrong.
How much is the probability then?
Well, assuming we do it this way, it's 0.363.
What do you think, Estrella? Do you think we need to fill in both the middle and the right side, or just the right side?
Do it with the middle.
Do it with the middle?
Yeah.
Well, because that brings it up to 0.637.
Oh, okay. I'm so screwed in because I get 0.5.
Okay, question is then what do we want to go with? We've got 28 minutes before this is due, and we're all locked out.
I say let's just do the middle and the right side.
Mm-hmm.
Okay. So that's 0.637. What is the probability that a randomly selected student will score below 600 on the GMAT? Now, I think that's one where we can go back to our z-score and do 600.
Yes.
It'll give us 0.478. And then we just do the left side.
How much is going to be?
0.316.
316?
That's what I got on my normal probability applet.
I didn't type in the new z-score. Ignore me.
You're good. I just figured since now it's mentioning 600, we should probably throw in the new number.
No, yeah. I got the same number now.
Okay.
Okay, so how much?
0.316. And then we'll score 600 or above on the... Oh! Guys, we did that other one wrong. Go back. To 22. It says score above. It's the same number.
Which one? For the 22 or for the 23?
22.
22. Because it scores this or above, you fill in 2. If it just says above, you just fill in the 1.
Okay, so how much is that one?
That's what I'm checking right now. Because I've got to do everything again.
Okay.
0.351. Oh, no, that's not what I meant. 0.351. Okay. 0.351. There we go. That. So it would be 0.363.
Yeah.
And then this one, what is the probability that a randomly selected student will score 600 or above on the GMAT? And then we have 0.479. And that one is 0.684.
That's what I got.
Okay. Okay, and then find the GMAT score that responds to the 10th percentile. Okay, assuming it's going off 600 since that's where it left us. For this one, if I remember correctly from my notes, we highlight only the left side. We type in the percentage here. We get that z-score. That's all I remember.
Yeah,
Right.
that sounds right to me.
Yeah, and then what we do is we take it over here. We take away x, and we fill in the z-score here, which is, in this case, negative 1.282. And that's our 10th percentile, is 387.768.
And then it says that we have to round it to the nearest whole number.
So that'd be
388.
Yeah.
The GMAT score that corresponds to the 90th percentile. Okay. Hold on, let's get back to the original. And let's put 479. And with 90th, you put it here. You put 0.9, enter, take that away. That's lovely. How is that the same, though? Oh, we do both of those. What?
I get 697.
Hold on 1 second. Give me a second, I might know where they are. Oh, 698 point. Oh, 698.
697. I don't know. Maybe I'm wrong.
Hold on. No, I typed in the wrong number. Yeah, 697. Is that what everybody else got?
Yeah.
Yeah.
Hold on. I know where they are. I will find them for you. I just have 23. Oh, okay. I was like, 23 minutes. Please. Find the first quartile of the distribution of GMAT scores.
So that's 75%?
No, the first quartile is 25%.
Okay.
Yeah. So
are we just using the numbers 388 and 697?
Yeah.
What? Oh, yeah.
For the first question and the second question, yeah.
Yeah.
I mean, the first one around this one. What did you get?
Hold on. What was the mean again? 542 point what?
3.
And then we have 0.479. And then we go here, click, highlight that, 0.25, enter. And then we get negative 0.674. Okay, so exactly the first quartile should be 461.
Yep.
Mm-hmm.
Okay, 28. Find the third quartile. And then we have 0.479, enter. Get those, and since it's over 50, we do that. And then we go 0.75, enter. Oh my gosh, it's the same answer. Why did I even do that? 0.674. All right, it looks like that one is 624.
Yep.
Yeah.
Save 29. And oh, here we go. Here's an N, here's an N, here's an N. Mean of the distribution of the sample scores. That's the exact same, isn't it? 542.54?
I get 542.3.
I don't care.
Because you have one decimal place, but Maybe I'm wrong. So
Well, what's the normal mean? 542.3. Okay, I was mixing up numbers. Yeah, it's 542.3 because it's the exact same mean. Now here's the one that's gonna screw. What is the standard deviation of the distribution of the sample mean scores for all such samples? That's the formula we were trying to use earlier that wasn't working. So
Wait, what'd you get for number 29?
29? 29 is, do you remember that rule where it's any mean is the same mean as long as it's normal?
Okay.
Yeah, so it's the same mean we've always had. And then standard deviation of the distribution of the sample mean scores for all such samples. That is x minus the mean over the standard deviation of n, right?
So
divided by square root of n.
Yeah.
So should we use the same n that is in the top? Like the 15 students?
Yeah.
Yeah.
Because that's the n we've been looking for. So we have 3.87. Let's go. Calc. Could we have somebody subtract the mean from x, which I think is 600?
Yeah, I got it.
Okay. And then n, let's see, standard deviation. Oh, wait. We can't do that one. This one's different. Because we're looking for the standard deviation, right?
Mm-hmm.
Standard deviation of the distribution of sample mean scores.
Yeah, so how would we get that? Because the formula we just said requires us to have the standard deviation already.
We already have the standard deviation. It's 120.54.
Oh, right.
We're still using the same.
Right, I forgot about that.
You're fine.
120.54. Seriously, and I've still got a long way to go. 3.873. Okay, so the bottom number I got was 31.123. Now, what was the other? What was the number?
57.7.
It's not just that. 7.7 divided by 31.123. I think Estrella's right again. I think we just did the probability to get the z-score.
Yeah, because the standard
I'm pretty
deviation.
sure you and I just did z-score, Caitlin.
Probably.
Yeah, I think she's right.
The standard deviation is the 3.1123.
Yep. Yeah, so the other one we just did good news. We went ahead and got the z-score.
And get this, yeah. So because it's 3 decimal places.
Wait, what was the standard deviation?
31.123, because the standard deviation of distribution formula is the standard deviation over the square root of n. It's the probability one that we did, which is the z-score formula over the standard deviation over the square root of n. And since we already have that bottom half, all we need is that top half, which we already did, which is 1.854.
Oh, yeah.
Okay, and then what's it want? Will be greater than 600. And I've already naturally had my cursor on the left side, so that's 0.032.
Okay, we're done.
All right, let's see if we got it all correct. Okay, got it. Oh, 0.67 of a point. Oh, so all three were correct on question 2. Question 9 we got wrong.
Let me check.
It's standard, calculate standard deviation of the amount spent.
What is the answer that we have?
1.09. 1.901.
Let me check.
No, you're good. I'm just trying to move on to see if we got anything else wrong so we can.
14.
What?
We got 14 wrong.
Yeah, we got 14 wrong as well.
22, 23, and 24.
Well, we suck.
No.
We'll score above. So that first one we probably had right. Below 600 was probably the same, but down. 600 or above. Okay, so those ones we may have flipped it. So 22 may
Yeah.
be both of them. 23 may like both of them on the right. 23 may be both of them on the left. And 24 is probably just the right.
That makes sense.
Okay. All right. So let's whip back through. Let's see if there is an option for a second chance. I'm sure there is, but we got to book it. Quite literally. So there's that. That's gone. I already did that, so I mean, if I don't have time, it's fine. I got my grade. Okay, does somebody have the other test open?
I have it open.
Okay. Because I want to fire off the answers and get... So the only ones we missed were which ones? Oh, 2, which is, we got 0.67, so it's all 3. We got that one right. Okay. 4. What was the answer to number 4?
Oh.
Stratified.
Stratified? Okay. I'm not even trying to read the questions. I'm just trying to get us through. 5?
Cluster.
6? SRS? 7 was stratified again?
Woo.
No?
Yeah. Sorry, my chair just did something weird.
No, you're good. What's the number for question 8?
4.771.
Okay, save. Move on. Question 10. I did that. 11. Did we get 11 right?
Yeah, it's negative 0.165.
Okay, 12.
0.681.
13.
None.
14. Was one
Got
we got
that wrong.
15.
False.
False. 16.
Extradural.
17.
8.
8. 18.
50.
19.
2.055.
20.
0.233.
We got 21, 22, 23 wrong. How about 24? Oh, okay.
We got 21 right.
We did. And that was D. 22, 23, 24 is what we got wrong. 25.
388.
6.
697.
7.
461.
8.
624.
9.
542.3.
30.
31.123.
And 31.
0.032.
Okay, now let's go up to 22, 23, 24, because those are like the quickest ones that we probably just missed by a simple mistake. Okay, so 600. Do I still have that Z formula up? No, I don't. 600. Oh my gosh, reset. Okay, so the numbers are 600, 542.3, and 120.54, right? Yeah, 479 is correct, from what I remember. 0.4, excuse me. 0.479, and the question here was we'll score 600 or above, so it's only that end, and so it's 0.316. And was that the answer we put?
Yeah.
That is the answer we put for 24.
No. Oh no, it's the answer we put before we changed it.
Okay, so put it 24. We'll leave it at that. Probability that a randomly selected student will score below 600 on the GMAT. And that one was 316.
No, it'll be different because you're using 600 instead of 542.3.
Well, I've been going backwards, so 24,
In
and then
that one,
23 is using the same.
In that one, I have, in the 22, I have 0.5.
Okay, we'll get there in a second. For about 23, it says below 600. So we'd be using the same formula because it mentioned 600. 22 is the 500 one.
Yeah, okay, sorry, I didn't know you were going backwards.
You know, I'm going backwards, just trying to go the other way. So what was the answer we got for 23?
The right one or the wrong one?
No, the wrong one.
0, well, okay.
0.316.
Okay, so then it's probably both of these because this line's probably 600 right here.
Yeah, 684.
Well, 0.684.
Mm-hmm.
Okay. And for this one, it's 500. We'll score above 542.3 on the GMAT. Wouldn't that just be the same answer we just got, or was that the one we put as the wrong answer?
What questions?
22.
22 is 0.5.
And how is it 0.5? Because that's the average, not the middle.
It says that a student will score above.
Yeah, above.
542.
Your mean, normally people don't score 50% above. Your median is the one they'll score 50% above.
That's a probability that randomly select a student will score above.
Yeah, but for 542, your mean, you shouldn't have that. Usually, like the mean includes like all the outliers, so the lowest scores and the highest scores. The odd that your mean is perfectly in the middle is very unlikely, which 0.5 is 50%. Now, if 542 was the median, if it was the middle, then it would be 50%.
Do you remember on the beginning of the test that you say, so this one, all are have to be checked? Isn't the first one?
What?
No. Yeah, that's okay. I will go and submit this one. If I get all right, I will give it to you.
Okay.
Oh no, actually, it's only one. Okay, this will be fun. Okay, so let's see.
Okay, so Kate, what was the one? What was the answer we got for 22? Because we've got 7 minutes to try to get a better grade.
0.363.
0.363. We'll score above 542. So couldn't we just say it's 0.68 again?
Yeah.
So I get the 0.5, the one that I told you.
Yeah.
And it's right.
It's right?
Yeah.
How did you get that?
What was that?
How did you get that?
Okay.
I think you broke her.
That's fine. Let's move back to 14.
Yeah, it is already, I'm already done. It's just
Wait, what did you get for 23 and 24?
23 and 24, I think we just flipped those answers. 24, we put 0.316, and for 23, we put 0.64.
And that's,
okay, thanks.
Sorry, 0.684. And those are correct too?
Yeah.
Cool.
Those are good.
All right, and 14, let's see. Up here, up here, up here, up here, up here. Standard deviation of these temperatures. Round your answers to 3 decimal places. And standard deviation is it's the square root of x minus x over n. Right?
Square root of x minus mean squared divided by n.
Okay. So x minus mean. Oh, wait, but they all have different means, don't they? No, they don't. No, they don't. Do you remember what the original? We didn't write down the meaning.
I have that one good too. You want the number?
I want to see if we can figure it. You know, we have 5 minutes. Screw it. What is it?
0.715.
Okay. And then how about number 9?
Let me look it up.
Because that was the one we used the software and it was incorrect.
Yeah. So it's 1.912. And I get that one right too.
Okay. All right.
And I think we did get it this one. Would I get it?
I mean, we did pretty good. We only missed like 5 out of 30.
Yeah. I just missed the
Oh,
first
crap.
one. But
It was only 1. That doesn't make sense, but okay.
Yeah. I told
question
you, I said,
2.
hey, it's only 1.
I didn't hear
the
that.
Same one.
That's
but
fine.
Then I was like, okay, I'm done. I have 97 out of 100. So you know what? I'm a genius.
Same
Let's
here.
Go sleep.
Oh yeah. Go to bed. You're probably tired.
Okay.
Yeah.
There we go. We're done. We can all sob ourselves to sleep tonight.
And then take the actual exam tomorrow.
Seriously.
Oh yeah, I will be so screwed. My goodness.
Okay.
For real though. Probably gonna take a power nap before I dedicate myself to the pages of notes I have to do.
Okay, good luck on that. Have a good night, everyone. Bye.
Night.
Care.